Welcome to Psychiatric Residency Edition. I am Dr. Thomas O'Leary, or T. Ryan O'Leary as I'm more commonly known. I'm a third-year psychiatry resident in the National Capital Region. This podcast is my endeavor to help myself take a deeper look into the human mind, and also into what we do as psychiatrists and why we do it. It's my own opinion and should not be mistaken for medical advice or for anyone or any institution's opinion. I am often wrong or mistaken, so take what I say here with a couple pinches of salt. Today's episode is the start of a series on brain networks. References can be found at the end of the show transcript, which is located at psychiatric.buzzsprout.com. More and more, neuroscientists are teasing apart how the brain works, and it's not simple. In order to find out what each part of the brain does, we used to have to damage it, like either intentionally or unintentionally, like when a stroke destroyed the tissue or when a lobotomy took a chunk out of your frontal lobe. By noting what functions were lost and what behaviors changed, researchers were able to make a crude map of what the different areas of the brain do. But behaviors are complex. One does not simply move one's arm. We respond to some external or internal stimuli that motivates us to decide to move our arm. And then we execute the action, generally for some reason. If our arm moves for no identifiable reason, then this is a problem. After executing an action, we decide if the outcome is satisfactory or not. During this whole process, we're also dealing with our feelings, like that pain in my shoulder, or that memory of having lifted that same object before and what it was like, or that tinge of guilt that I didn't rinse that plate and then stick it in the dishwasher before the spaghetti sauce hardened into an epoxy. All these things, these thoughts, need to be dealt with, and somehow our brain has decided what to give its attention to and what to think about it and what to feel about it. We have networks of neurons functioning in systems, some of which ramp other systems up and some of which dampen others down. This ballet of correlation, when increased activity in one network predicts increased activity in another, and anticorrelation, when increased in activity in one network predicts decreased activity in another, can help us understand what's going on in the brains of humans who are normal, or at least approaching normal, and those who have psychiatric disorders. It can also help us to develop better targeted treatments that will hopefully more predictably increase or decrease activity in selected areas of the brain. Today, I want to discuss a single network in the brain, the default mode network. In future episodes, I'll explore the interplay of other networks in the brain like the salience network and the dorsal attention network that function together to help us decide what to pay attention to and how to react to stimuli or not to react to stimuli. And I'll also discuss in more excruciating detail how the brains of humans reporting criteria of certain psychiatric disorders differ in their networking from those that do not report psychiatric symptoms. But for now, just imagine that you have entered a quiet room with nothing in it but a soft pillow in the center. You sit on that pillow. You close your eyes. And you become aware, primarily, of your own thoughts. You have just ramped up parts of your default mode network. The discovery of the default mode network seems to be traced in a large part to Rakel and colleagues in a paper published in about 2001. The primary author, Marcus Rakel, also wrote a paper in the Annual Review of Neuroscience in 2015 called The Brain's Default Mode Network. And this paper described how this network was discovered and what we know about it, at least up to 2015. To summarize, neuroscientists used to take resting state scans like PET scans and fMRIs of the brain before making people do a task, and then they would take a scan of the same brain during or after a particular task was performed. I'll quote Rakel here. At some point in our work, I do not recall the motivation. I began to look at the resting state scans minus the task scans. What immediately caught my attention was the fact that, regardless of the task under investigation, the activity decreases almost always included the posterior cingulate and the adjacent precuneus. Unquote. This meant that when the brain started a task, it dampened down in a predictable way another part of the brain. That part being the posterior cingulate gyrus and the part of the precuneus right next to it. So to help us understand this a little bit better, just imagine you grab a brain. It's sitting on the table. You wrap your hands around the two lobes, and then you split it apart. You would have a clear view of the medial prefrontal cortex, the precuneus and the cingulate gyrus, which is hugging the corpus callosum. The cingulate gyrus is described often as part of the limbic system, but it also talks to the regions of the brains in the cortex and all the way down to the spinal cord. The cingulate gyrus is amazing. The more anterior parts of it, closer to the front, play a huge role in emotional regulation. The middle part, the medial part, is intimately involved with the reward centers of your brain, and the posterior part is really active in visuospatial orientation and memory processing. Overall, it does a lot of tasks that have been crucial for humans and our ancestors deep into evolutionary time. It just so happens that the rear or the posterior part of that cingulate gyrus butts up against a region of the brain just superior to it on the medial parietal lobe, called the precuneus. The precuneus also has been shown to play crucial roles in understanding visuospatial relationships and activating episodic and semantic memories, and in contributing to our sense of self, a sense that we have our own agency, one part of our identity system. The default mode network is especially concerned with thinking, and especially thinking about ourselves. In the precuneus, the anterior part seems to be more involved in the visuospatial, self-referential, and consciousness-making tasks, and the posterior part in memory activation, similar to the neighboring parts of the cingulate gyrus. In a way, they can be thought of really as kind of the same thing, with different names. Another area of the brain is also active when humans stop engaging in designated tasks and just start thinking, especially about themselves, and that's the medial prefrontal cortex. The medial prefrontal cortex is intimately linked with our memories, emotions, and our senses. And it's really important for linking our past with our present. It's crucial for determining how we feel about what has happened and what is happening to us, and how we place ourselves in a social context. That makes the medial prefrontal cortex crucial for how we plan our actions. Together, the posterior cingulate and the precuneus and the medial prefrontal cortex form the bulk of our default mode network. But other parts of the brain are involved too. A more complete or more descriptive list includes the ventral medial prefrontal cortex and the dorsal medial prefrontal cortex, the posterior cingulate cortex or cingulate gyrus, and that adjacent precuneus, plus parts of the lateral parietal cortex. This default mode network most obviously engages when we're able to relax and focus on ourselves, put ourselves in the context of our past, put ourselves in the context of ourselves. But that's not the only time it's working. First, let me back up to the medial prefrontal cortex, because I lumped a lot of things that it does together before. But really it has kind of two different parts. There's the ventral medial prefrontal cortex, and that seems to link our senses with our emotions in a really complex way, and that can include social context. This part, the ventral medial prefrontal cortex, is crucial for determining our personality and regulating our emotions and dealing with things like anxiety. One part of this same area, it's been described as the agranular subgenual portion of the ventral medial prefrontal cortex, has been shown to play a large role in mood disorders. And in rare cases, they've shown that stimulating this area with implanted electrodes is effective at treating intractable depression. Now, the other part of the medial prefrontal cortex is the dorsal medial prefrontal cortex, and just a little further back. It seems to be more important for answering questions like, do I like this or not? And what does this mean to me? Rakel summarizes it like this, quote, "Data from humans suggest that the default mode network instantiates processes that support emotional processing, self-referential mental activity, and the recollection of prior experiences," unquote. Now, it's tempting to think, and I think commonly misunderstood, that the default mode network turns off when we're not engaged in our deep thinking, or what neuropsychologists like to call spontaneous cognition. But this is not the case. The default mode network seems to always be functioning, but different parts of it are functioning at different levels at different times. For example, the lateral parietal portion demonstrates much greater connectivity to the hippocampus in the evening than it does immediately after a good night's rest. When other areas of the brain turn on, parts of the default mode network may tone down a little bit. This correlation and anticorrelation is likely a crucial process in many disorders if it's not functioning correctly. And even when you're not daydreaming and you're not really fully conscious of your thoughts, like when you're under anesthesia or in early stages of sleep, the default mode network seems to still be functioning. This network seems to be a critical part of the mammalian brain, and it's not likely that other mammals spend as much time in self-referential ponderings as humans do. So the way that it developed historically means that it must be serving a very crucial and basic function for these animals. We don't know all the details about what that function is yet. In future episodes, I want to get into more of the research on how the default mode network interacts with the rest of the brain, like that salience network and that dorsal attention network. This can give us some insight into why some people, say, respond to medications versus psychotherapy, or why some people don't respond to anything that we do. But that is for the future. Thank you for listening. I am Dr. O, and this has has been an episode of Psydactic Residency Edition.